Hey guys, this is Taylor here, and today we are solving the problem number 3634, which is minimum removals to balance array. And this problem is from contest, biweekly contest 162. So let's get started. So you are given an integer array nums and an integer k. An array is considered balanced if the value of its maximum element is at most k times the minimum element. You may remove any number of elements from nums without making it empty. Return the minimum number of elements to remove so that remaining array is balanced. And size one array will be always balanced. So we have given some array, and let's try to explain understand here. So let's try this case 161269. Okay, 1 comma 2 comma 6 comma 9. In case equal to 2, k equal to 3. Okay, what we need to do? So we need to compare our minimum element and maximum element. That's why I have sorted the array. So the very first thing that we'll be doing here is sorting, because we need to every time compare the minimum and maximum element. So I need to check whether my minimum element satisfying the condition. So 1 into 3 equal to 3, and my maximum element is 9. So is 3 is greater than equal to 9? No, it is not. So this array is not satisfying condition. Now I need to do two things. Either I can remove one element from here, or either I can remove one element from here. So let me try one thing. Let me try removing it from here for first. Okay, now I will check again. So 2 into 3 equal to 6, and my max element equal to 9. So is this satisfying? 6 is greater than equal to 9? No, it is not. So I need to remove one more time. So I will try to remove it from here this time. Okay, so this is my remaining element. So 2 into 3 is equal to 6, and 6 is greater than equal to my 6, and this 6 is maximum. So is this satisfying the condition? Yes, it is satisfying. So I can say that after removing two elements, this one and this one, I got my answer. Yes. So let's try run one more test case 125. So let's quickly try run this. Now my k is equal to 2, I think. Yes, my k is equal to 2 here. And okay, so is this satisfying the condition? 1 into 2 is 2, and 2 is less than equal to 2 is greater than equal to 5. Is this satisfying? No, it is not satisfying. So I can either remove this or either I can remove this. Okay, so let me try to remove this. We will see how we are removing this, why we are removing this. But let's try. Okay, we are removing this part. So I am here now. 1 into 2 equal to 2, and 2 is less than equal to 2. So my condition is satisfied, and I think, oh sorry, it should be 2 greater than equal to 2. This 1 into 2 wala this here, and this maximum 2 is here. Okay, so the minimum element into k should be greater than equal to my max element. So this is the condition that I need to follow. Okay, I need my array to follow. I need to make it balanced. This is the condition to make it balanced. So I hope you got it. Let's try to understand what we can do. Okay, so guys, there are basically two approaches to solve this problem. The first approach is basically binary search, okay, which we will be seeing in this video. And the second approach is sliding window. And the time complexity, if we talk, so this complexity is n into log n, and its time complexity is n. Okay, both the space complexity is constant. So in this video, we'll be checking this, and in the next video, we'll be checking this. So make sure you watch this optimal solution as well. And okay, let's get started. Here I have written two examples, and here we will be checking. Okay, will the greedy approach work? Okay, so we will be discussing the greedy approach first, because there is only two possibilities. Either I can remove element from here or here. So what I have written here is, so this is my array, and here is the its differences. Okay, so 2 minus 1 is 1, 5 minus 2 is 3, 16 minus 8 is 8, 39 minus 16 is 23, and similarly here. And what my greedy approach, what my mind is saying is, so this is my long array, okay, and here my difference is 34, here my difference is 8, and I need to get something like this, so that my condition with like this, the minimum of array into k is greater than equal to max. I want to reach this condition, okay? And to reach this condition, if like in greedy way, if I will think so, if this is my maximum difference, if I can reduce this, so this element and this element, this can come more closer, right? They are come like becoming more closer, and I can reach to this condition very fast. So this is my greedy mind is saying. So let's see whether it is working fine or not. So here is the test case I have taken. So in this case, let's try to diagram. So this one is there, this three is there. My greedy mind is saying that, okay, let's remove this part. Okay, let's remove this. So I have removed one, and one into two, basically this two equal to two, and this two is less than greater than equal to two. So condition is satisfied, and one if out after removing one, I got my answer. Okay, so I think greedy worked here. Let's try to check whether greedy working here or not. So here is 34, here is 8. So my greedy mind say, let's remove this. So my count is 1. Okay. Now 26 and 8. My mind is saying, let's remove this. Count is 2. Okay. Now we have 8 and 23. So my mind is saying, let's remove this. Okay. And I was keep checking. So this was not satisfying my condition. After removing this part, this was not satisfying condition, and after removing this was also not satisfying condition. So after I remove this, okay, my k is 3 here. So 8 into 3, 8 into 3, it's 24, and 24 is less than 39. So my condition was not satisfying, but when I compare with this, the condition is satisfying. So I can say that after 3 removals, my array becomes balanced. So how much iterations I took? I think 3. But is this a correct answer? Can you think? No, it is not. So what will be the correct answer is, let me write down it again. So the correct answer, if you see now, if I remove this and this, and this will be my balanced array. How? So 39 into 3 is I think 117, and 117 is greater than this. So after removing two elements, I got my array balanced. So greedy approach definitely failed. Okay, so greedy will definitely not work. I need to think something else. Okay, so let's see what intuition we can apply to this question. So let's discuss the intuition of this problem, and intuition is very interesting. So we just have two options. Either we can remove elements from here, and we can remove elements from here. Okay, so let's think about possibility. So if I think something like, if let's say I'm not removing any element from here, okay, the best case. So I'm just trying to figure out, if I don't remove any element from here, and if I multiply 8 into 3, how many elements do I need to remove from the right side to make this thing like to make this array balanced? So let's see. So if I do something like this, I got 24, and to make this balance, I think I need to remove this, because this 99 is greater than 24. I need to remove this. I need to remove this. Yes. I need to remove this. Yes. Do I need to remove this 16? No, I don't think so. So if I remove numbers till 39, I think these three elements, so my array will get balanced if I don't remove any element from the start index. Okay. Okay. So this is the first, when I am removing zero element from the start index. Let's try the second case where I will be removing this 8 from the start index. Okay. So let's try this. So let me change the color. So I am here, and 16 into 3 will be, okay. So I have written the multiplications here. So 16 into 3 is 48. So if I let's suppose I am removing one element from the left side, what are the number of elements I need to remove from the right side to make this array balanced? Okay, let's try to figure out. So do I need to remove this 99? Yes, I need to. Okay, let's remove this. Do I need to remove this 65? Yes, I need to, because this is greater. Okay. Do I need to remove this 39? No, I don't need to. So after removing two elements from here and one element from here, my array is balanced. This array is balanced. If you say 16 and 39, property is satisfying. So 16 into 3 is 48, and 14 is definitely greater than, okay. This 48 is greater than this 39. So my property is getting satisfied. Now let's try this part. Okay, let me try this. And from left side, how many elements I have removed? I think two elements I have removed. Okay, now I will check, if I am here, 39 into 3 is 117. How many elements do I need to remove from the right side? So my 117 is already greater than this. So I need to remove these 0 elements from here. So my resultant answer will be in this case. So 39 into 3 will be 117. So this is the one element removed from the left side. Okay, left side, left side, left side. I need to remove two elements. And the right side, I need to remove here. I think 3. Here I needed to remove, I think 48 thana. So 3 elements again. And sorry, it should be 2. And here I need to remove 0 elements. Okay, so my overall cost is 3 here, my overall cost is 3 here, and here I have my cost is 2. Okay, let's try further. So let's try 65. So 65 into 3 is 195. How many elements I have removed from the left side? I think 3 elements. And how many elements I have removed from the right side? I think 0, because this 195 is already greater than this. So my overall cost is 3. Okay. And as soon as I reach this n minus 1 index, so I can stop. So I hope you got it. So if we try to find out this number, okay, so let me write array again here: 8, 16, 39, 65, 99. Okay, I am, let's say, here, and 16 into 3 is, let's say, 48. So I need to check, is this greater? No. Is this greater? No. Is this greater? Yes. So here I can basically place my 48. So just to find this array, I will not be doing a linear search, but I will be doing a binary search. Okay, so that's all the intuition about this problem. And if we can apply binary search on this part, so we can definitely solve this problem. We just need to figure out how many elements we need to remove from the right side, and left side element remove, it's very easy. So if whatever my index is, so I have removed that much element. If my index is 0, that means I have removed 0 element. If my index is 1, that means I have removed 1 element, right? This element. So that's all the intuition about. So let's quickly write some pseudocode. So if you know upper bound, if you know upper bound in binary search, what does that mean? So that means is, my if my array is something like this: 1 2 2 2 2 and 3. If I try to ask binary search that, okay, if I try to place 2 in this array, so just to maintain the order, I think I can place here as well, here as well, here as well, here as well. Okay, this new 2. So upper bound will always tell me the index that make it here, and my lower bound will always tell me that make it here. Okay, so why we are finding upper bound in this case, that is very important. So let's say I am here. Okay, my 1 is here and my k is equal to 2 here. Okay, so I'm, let's say, here. I'm trying to find how many elements do I need to remove from the right side. Okay, so what is the ideal answer? You know, guys. Okay, if I remove one element, I directly got 2, and this 1 into 2, 1 into 2 is equal to 2, and this 2 is greater than equal to this 2. It is satisfying my condition, yes. But if I use lower bound now, it will tell me 1 2 3 4, remove 4 elements. Okay, but that is not correct. I just need to remove one element. That's why I'm trying to find upper bound here. I hope you got it, why we are finding upper bound. So we will just be using inbuilt binary search function. I think every language contains this. So we'll writing the pseudo code here. uh, if you write in C++, Java, or JavaScript, please follow me along. The code is in description. You can check that. Okay, so I think we can start writing pseudocode. But before this, let's discuss one more case. So we'll be using something called as upper bound here, right? So what I will be doing is, let's say I got this 39, okay, and 39 into 3, I got 117. In that case, if I try to find upper bound, what that upper bound will return me? Upper bound will return me something like the index 5, right? So what does that mean? If I got index 5, how many elements I need to remove? I need to remove from the left side. I think 2. Yes. Yes, I need to 2. But from the right side, do I need to remove anything? No, I need to remove 0. So if I got any time, if I got j greater than equal to n minus 1, okay. So this j is my the binary search answer. Okay. So if I got any j which is greater than n minus 1, then what I need to do? I need to make my answer, or my cost will be equal to I. So I just need to remove elements from I. Otherwise, if I got something like let's say you are here, let's say, and you need to remove elements still here. So I think if I got two, okay, let's say two. So what I need to do in that case? So my answer will be I. Okay, I will be 0 plus whatever my index, this n, this 5. Okay, 5 elements are there, so 5, and this 2. So the answer, if I write something like this, I is 0 plus whatever my n is, 5 minus the 2. So what I got, 3. So that way I can get that, okay, I need to remove this 3 elements and I will get my answer. Okay, so we'll be using the same formula. So let's try to quickly write pseudocode now. We are good to go. So my mini will be infinite. I will be treating from I in range. I think n. What I need to do? So let me write like this. I equal to 0 to n minus 1, or I think I can iterate till n also. That's not a problem. So my left cost will be equal to I. Okay, whatever my I is. My right cost equal to upper bound. Okay, I will be finding upper bound. You know upper bound is, right? Upper bound of my array. My target is basically nums into k, nums of I into k, and my array indices will be I plus 1 till n. Okay, so my right cost will be like this. Now, if my right cost or right index, it should be right index, it should be j. Okay, if j is greater than n minus 1, then my cost will be only I. Otherwise, my cost will be I plus n minus j. Okay, and in the last I can compare mini equal to min of mini comma cost, and in the last I can definitely return a mini. Okay, so this was the approach of this problem. Let's try to code this quickly. I think you got it. How we are solving this. Let me write code for it. So n equal to length of nums, and mini will be infinite. In the first go, I will start my I pointer from this. What I need to do, my left cost is I, definitely I know. J, I will try to find the upper bound. So in Python, I can input bisect right for finding upper bound, and if I need to find lower bound, I can import bisect left. So I can pass bisect right here. My array is nums. My target is, okay, my target is nums of I into k. This is my target. And what is the index range I need to find? I plus 1 till last. This is my index range I need to find into. And if j is greater than n minus 1, I can directly return my cost, overall cost, as I think I. Okay, so whatever my left cost is, that will become my overall cost. Otherwise, my cost will be left cost plus n minus j. Why we are doing plus n minus j? Because let's say if somebody tells that, okay, you need to remove 3 elements, so how you will figure out? So in this case, upper bound tells me that I need to place my number here. Okay, so whatever my number I'm getting is, let's say 8 into 3, it's 24. So 24 I need to pick, put somewhere here, right? So upper bound will tell, okay, you need to put here. Okay, so I got 2. Now I need to find the length of this. So how can find 5 minus 2, 3? I think this way I can definitely find this, right? So that way, that's why I'm doing like this, and I can compare my mini to minimum of mini comma cost, and I can return mini here. I think we are good to go. Let's try to run this. Okay, we are getting the wrong answer. What will be wrong? Okay, so I forgot the very important thing, which is sorting. So I just need to sort the array, which is very important. Otherwise, my approach will definitely fail. Okay, it's working fine. Let's try to submit this and see whether it's working fine or not. Okay, it is working fine. So, guys, we have discussed this binary search approach, and we have definitely optimal approach, which is based on the sliding window. So we can optimally calculate that. So please make sure you watch that video as well. And if you have any doubts in this video, please make sure you comment and get it resolved. Because if you have doubts, so it's ideally should be resolved. Okay, thank you very much for watching this video, and we'll meet in the next one. Thank you.